How should we think about automating complex production? Coordinating the flow of resources through multiple stages of production with multiple end products is a lot different than building a simple furnace column. Completing the Jumpstart Factory by adding research is a good time to explore this. First principle, when you're learning, always leave extra space, roughly twice as much as you think you'll need. We won't need to expand the essentials area as far as I've laid it out here with these ghosts, but using a small amount of extra transport belts is far better than having to tear down a bunch of your factory because you didn't leave enough room. Second, get specific about what you want to make and how much. Do some research is not specific. 15 science packs per minute, both the red automation and the green logistics packs that we'll be unlocking soon, that's a specific target. Most of the logistics tier projects have a 15 to 30 second timer per pack, up from the 10 to 15 we've had with automation. At the longer 30-second timers, that's 2 packs per minute per lab. We'll also get research speed upgrades, a total of 50% along the way, boosting that to 3 science per minute per lab. At least 5 labs needed to hit our goal, I'm going to go with 6. When you've decided where you're going, start working on a prototype from the top down. There are always trade-offs, we'll be looking at some examples of those, but there's almost never a one best way. There are many ways to build a good factory, and you can't optimize for everything at once. When expanding a research zone, daisy chaining is one option. Since all the labs want the same ingredients, they can grab from each other instead of grabbing from a belt if you want to do it that way. I prefer the belt access route as opposed to having more inserters moving the same pack back and back to the labs in the rear, but to each their own taste. I'll throw a few labs on each side of the belt, and we could make this longer further downward if we needed to. Then we'll need assemblers for the science packs. 2 assemblers for each type to keep up with these labs, leaving 4 here, again, space for expansion. Automation science packs on the left, they'll output the science packs into the middle transport belt, and then on each side we'll need to supply those assemblers. If you recall, automation packs are just copper plates and iron gear wheels. We can just ship those in via belt. Logistics is a little more complicated. Those require an inserter and a transport belt. The inserter chain is on the right here, and that's going to require even more stages of production. The gear wheels can just flow in, but they need electronic circuits, which needs copper wire. I've left this gap in the transport belt so that all the resources can reach the inserter and the transport belt assemblers, but they won't flow onto the output one that's going to go down to the logistics science pack assemblers. As always, there are other ways to do it. That's all for the prototype. Then the question becomes, where and how do we want to hook this up to the rest of our factory so it can get the resources it needs? One way, not optimal but it works, is just to haphazardly hook it up with belt spaghetti to whatever the nearest source is that's available. It's definitely an opportunity to experiment with various belt mechanics, but as your factory grows, it will get harder and harder to cram everything in if you aren't a little bit more organized. We've mentioned filtering with splitters before, but here's a practical example. We want all the iron plates and gear wheels that we have available coming down these belts, but we want to recombine them in different ways. So first we want all the iron plates on a belt and all the gear wheels on a belt. As we split these, I've got the gear wheels going to the top and bottom belts, iron plates to the middle two, make it a little easier to combine them. If you haven't already, please consider liking the video, subscribing, and leaving a comment below with your thoughts. Half of the iron gear wheels get routed to the automation side with help of more fun from undergrounds, and a recombined belt of iron plates and gear wheels heads over to the logistics side, finishing the supplies needed over there. This would work especially for a temporary setup, but there are other approaches to consider. We could try the just cram it in method. We're already producing most of what is needed for the research in the essentials area as it is. In fact, the only thing that isn't there is the inserters. If we slap down another assembling machine, only minor surgery is required to get that set up. Iron plates and gear wheels are already accessible. Clear some space with undergrounds as usual, run a supply line for the electronic circuits, and we should be in business. While we're at it, we could throw some inserters in a chest, and that's one less item we need to craft ourselves. Hook up the power, and we're set on the ingredients for green logistics science packs. Automation could go anywhere. We could just set the assemblers in the grid itself, or we can divert some of these routes closer to where the logistics is. Gear wheels only, but we don't want to put a filter on the splitter for the main line, or it's going to cut off supply further to the right. A second splitter immediately afterwards, though, can use a filter and we'll be all set. Bring some copper plates up, do a little bit of belt maneuvering, and we'll be all set with a nice science setup. There are some potential hiccups with this idea. If we scale up the science, we could start running low on circuits, and we're diverting resources in the middle of the essentials area, so if we add more down the road, we could be getting our science just fine, but running low on supplies. Keeping in mind the potential flaws of those first two approaches, this is what I'm going to go with. Maintaining our priorities by being at the end of the essentials area. Future expansion is supported, as you can see by the various ghost structures. Utilizing the existing belts of resources, automation on the bottom, logistics on the top, avoiding any particularly unnecessary belt spaghetti. Certainly there are thornier engineering challenges to come, but if we keep our heads on straight, be specific about what we need, break down the structure into smaller parts in an organized prototype phase, and handle the flow of resources to the factory in a reasonable way, we'll be able to handle them as they come. The jump start is complete. Next up, we'll begin thinking about transitioning to the middle game.